Welcome to How AI Models Work. Imagine you are chatting online with, like, a customer service representative.
Okay.
They are incredibly polite, they remember your name,
Yeah.
they apologize for the delay, and they type out this perfectly tailored solution to your problem. But then you realize, wait, you aren't talking to a person at all.
Right. Yeah.
You are talking to a highly complex piece of software doing math at the speed of light. That is exactly what we are digging into today as we explore our January 2026 guide. If you've ever used an AI assistant, you know how easy it is to imagine a hidden person on the other side of the screen.
Oh, definitely.
Because the chat interface feels so familiar, it really feels like there's a mind in there, something that understands, remembers, and, actively judges the conversation just like a human would.
And that is exactly the illusion we're going to dismantle today. The main goal of this audio guide is to help you stop treating AI like a mystery and start seeing it clearly for what it actually is.
Which is a mechanical system.
Yes, a mechanical system. By looking underneath the surface of that clean chat interface, we can understand why AI sounds so human, why that specific trait can be highly misleading, and what is actually happening mathematically behind the screen when you hit send.
Right.
We need to stop treating these systems as hidden people and start understanding the mechanics.
Okay, let's unpack this. To break that illusion of the hidden person, we first have to understand the literal building blocks of how the system processes your text.
Yeah, that's the best place to start.
When you type a sentence, the AI doesn't read it the way you or I do. It uses something called tokens. You can kind of think of tokens like puzzle pieces of language.
Right, and it's a very mechanical process. A token might be a whole word, but often it's just a single syllable or a prefix or even just a punctuation mark.
Oh, wow. So it breaks it way down.
Exactly. The AI system takes your prompt, breaks it into these puzzle pieces, and assigns a specific number to each piece. From that point on, it operates entirely on math, not meaning. It doesn't see a question about the weather, it sees a sequence of numbers.
And that brings us to how it learns from data. Because
Mhm.
people often say an AI has read the entire internet.
Yeah, I hear that all the time.
And I think that phrasing implies it went to the library, studied the data, and internalized facts, ideas, or universal truths.
It absolutely implies that, and it's entirely wrong. During the training process, these models don't read to learn facts. They absorb large-scale statistical patterns over billions and billions of tokens.
So what is it doing with those tokens?
The system is simply running equations to figure out which numbers, meaning which puzzle pieces, tend to follow other numbers. If the word peanut appears, the word butter has a high statistical probability of following it.
Right, that makes sense.
The model is just adjusting its internal parameters to reduce the mathematical error in those predictions.
But hold on, I have to push back there.
Yeah.
If it's just doing math on puzzle pieces, how is it answering my questions so well? I mean, I've seen it explain incredibly complex topics like string theory or tax law in plain English. It really feels like it truly knows the answer. Are you saying it has zero comprehension of what it's saying?
What's fascinating here is that, yes, it has absolutely zero internal comprehension. The AI does not understand, believe, want, or think like a person does.
Wait, really? None of that?
None of it. It has no internal awareness of the topic it is discussing. What you are interacting with is an advanced prediction engine. It is continuously guessing the most likely next token based on the massive web of patterns it learned during training.
So when it gives you a brilliant explanation of tax law, it isn't demonstrating that it went to accounting school.
No, not at all. It's demonstrating that it has successfully mapped the statistical structure of how human experts write about tax law.
Wait, if it's only looking at the statistical relationship of those puzzle pieces, it doesn't actually know if a historical date is true. It just knows that the year 1776 frequently appears next to the word revolution.
Precisely. It maps frequency and proximity, not truth.
And that causality perfectly explains our next topic, which is why a smooth, articulate AI answer can contain one wildly wrong detail. We have all experienced this everyday hook.
Oh, yes, the classic hallucination.
Right. You ask the AI for a fact, maybe the summary of a famous book or a historical timeline, and it delivers a beautifully written, perfectly formatted paragraph that happens to be completely false. How does it lie so convincingly?
It happens because of how human experts write in the training data. Think about articles, encyclopedias, and professional tutorials. They are naturally written with a confident tone.
Sure, humans write those to sound authoritative.
Exactly. When human experts write, they sound certain. They have a specific rhythm and vocabulary. During training, the AI learns that sounding certain is the statistically correct pattern for an informational answer.
I see.
It essentially mimics the swagger of an expert without doing the underlying homework. It replicates that confident style regardless of whether the specific tokens it predicts are factually accurate. Confidence, in the context of an AI model, is just a learned style.
Here's where it gets really interesting. Because the AI is so good at mimicking that authoritative tone, we naturally drop our guard. We assume that if something sounds professional, it must be correct.
We definitely do.
But we have to remember, and this is key, a polished answer is not automatically a checked answer. The fluency of the text, basically how pretty the paragraph looks, is completely separate from the verification of the facts inside it.
That is such an important distinction. A standard language model is not built to halt, pause, and verify.
Right.
Unless the system is explicitly connected to an outside tool like a live search engine or a database, it cannot stop and check a claim against reality. It has no mechanism to look out into the world and check its own math.
It just keeps predicting.
Yeah, it simply predicts the next plausible token until the response is complete.
Once you realize that AI isn't fact-checking its own output, it becomes much easier to see that other frustrating behaviors are also mechanical limits, not human flaws.
Like what?
Well, for instance, forgetting what you just talked about, I deal with this all the time.
Oh yeah, that's a big one.
You give the AI a strict correction. You say, do not use bullet points. And 5 minutes later, it completely ignores your instruction and gives you a bulleted list. It feels incredibly careless.
It does feel careless, but that behavior is a direct result of something called the context window.
It's a context window.
Yeah, processing tokens requires immense computational power. So every model has a hard mathematical boundary on how much of the conversation history it can keep active at any given moment. That strict limit is the context window.
I always picture the context window as working at a tiny desk. You can only fit so many papers on this desk.
That's a great analogy.
Yeah, when we start a chat, the desk is empty.
Uh-huh.
As new papers, meaning your new prompts and the AI's new answers get piled on, the desk eventually gets totally full.
Exactly.
And as you keep chatting, the oldest papers are shoved right off the edge to make room.
That analogy perfectly illustrates the mechanics, and it's vital to reframe how we view this limit. AI forgetting is not like human forgetting.
Right, because if I forget a detail from our conversation, it might be because I got distracted or I just didn't think it was important.
Exactly. And AI does not choose what is important to keep. The text simply stops existing for the model once it drops out of the available context window.
It's just gone.
Yes, it's a built-in design constraint to keep the system running efficiently. It's not a bug, and it's certainly not a sign of a lazy machine.
Okay, but this brings up a huge contradiction. If the raw model is just a limited prediction engine with a tiny desk, why does the final product I use act so polite, cautious, and helpful?
That is a very good question.
I mean, the raw prediction engine you're describing sounds like it would just spout out whatever random text it finds on the internet.
And it would. A raw model, straight out of initial training, is essentially an unrestrained pattern matcher. It is not inherently helpful.
Interesting.
To make it useful and safe for the public, developers have to apply several specific layers of shaping.
Right, and this is crucial. The answer you see is shaped by layers. This is exactly why you can ask two different AI tools the exact same question and get wildly different quality answers. They have different layers applied.
Exactly. Let's break down the mechanics of those layers from the January 2026 guide. First, there is fine-tuning.
Okay.
This involves taking the raw model and adjusting it on smaller, highly curated data sets to improve specific styles or performance on narrower tasks.
Like giving it thousands of examples of Q&A formatting so it learns that when I ask a question, it should provide an answer rather than just generating a second similar question.
Yes, exactly. Then there is RLHF, which stands for Reinforcement Learning from Human Feedback. This is where human reviewers compare different responses from the model and rank them.
Wait, let's slow down on that one. How does a human clicking a thumbs up or thumbs down actually change a mathematical prediction engine?
Great question. When human reviewers rank responses, those preferences are fed back into the math. It actually shifts the mathematical weights inside the model.
Oh, so it changes the underlying numbers.
Yes. If humans consistently prefer polite answers over rude ones, the model mathematically adjusts so that polite tokens become statistically heavier or more likely to be chosen than rude tokens. It nudges the AI statistically toward behavior that users find helpful.
So it's essentially altering the puzzle pieces so the friendly ones naturally float to the top.
Exactly. Next, we have alignment. This is the broader process of statistically guiding the system to be safe and predictable, ensuring it avoids generating harmful patterns it might have seen in its raw training data.
Got it.
And finally, there are guardrails.
How are guardrails different from fine-tuning or alignment?
Unlike the previous layers, which alter the internal math of the model itself, guardrails are external. They are real-time enforced rules and filters that sit directly between the model and the user.
So they aren't part of the core math.
No, think of them like a bouncer at the door. They monitor the text you put in and the text the AI tries to put out, and they can completely block or redirect a response if it violates a strict safety policy.
Okay, let me ask a highly relatable question based on all of this. If RLHF uses human feedback to shape the model, then when I correct the AI in our private chat, is it learning from me for next time?
Ah, people ask this a lot.
Like, are my corrections tweaking those mathematical weights in real time?
That is a very common misconception, but no. The model does not learn from individual users in real time. Your conversation happens in an isolated instance. It does not rewrite the model's core internal parameters.
But I've noticed an AI I use every day suddenly getting better at formatting my emails over the course of a month. How is that possible if it's not learning from me?
If an AI's behavior suddenly changes, it is because the developers released a new model update. They gathered massive amounts of data offline, rebuilt or retrained the system with new fine-tuning or new guardrails, and swapped the old version out for the new one.
Oh, so it's just a software update.
Yes, it's a software update. It is not because the AI gradually grew wiser from its daily conversations with you.
Knowing that AI behavior is so heavily engineered and layered, how do we make sense of the constant headlines? A benchmark score sounds incredibly impressive.
Sure, they make a big deal out of them.
We hear that a new model aced a bar exam or achieved human-level reasoning. But based on everything we've talked about, it sounds like those scores don't explain everything going on in the hood.
If we connect this to the bigger picture, we have to look critically at what these benchmarks actually measure. Benchmarks evaluate performance on highly structured, fixed format tasks.
Okay.
When a model aces an exam, it proves that it has exceptionally strong pattern matching capabilities for that specific format of text. It proves task performance. It absolutely does not prove human-like understanding or comprehension of the subject matter.
So it doesn't actually understand the law when it passes the bar.
No, it just means the sequence of tokens required to pass a multiple choice test was well within its statistical mapping.
But I have to push back again here. So what does this all mean for AI reasoning? Because when I give a model a complex logic puzzle or ask it to debug a piece of code, and it breaks it down step by step, explaining its work as it goes,
Yeah, that looks very human.
it really looks like it is thinking through the problem. How can you tell me it's not reasoning?
When an AI breaks things down step by step, it is just replicating chain of thought patterns that it saw abundantly in its training data. Human programmers and logic experts write out their steps when explaining things online.
Where they show their work.
Yes, and the model has learned that generating step-by-step text often leads to a statistically more accurate final token. It's a highly useful illusion, and it makes the output much better, but it is not internal thought.
It isn't actually pondering the options.
No, it is not weighing options in a conscious mind, doubting itself, or having an aha moment. It is simply generating the sequential tokens that represent a logical process.
It's mimicking the syntax of reasoning without the conscious experience of reasoning.
Exactly.
And that brings up the scale factor. Because every few months, a bigger model comes out, and a bigger model always feels smarter.
Oh, definitely.
It writes more beautifully, it handles edge cases better, and the illusion of the hidden person gets much, much stronger.
Larger models have more parameters, which means they can capture and reproduce much more complex statistical patterns. That is why they feel smoother and significantly better at handling nuance.
That makes sense.
However, increased fluency does not erase their basic mechanical nature. They are still prediction engines. And here is the trap. Because larger models are so fluent, when they do make a mistake, they can make very confident, highly polished mistakes.
Right. Back to that confident but wrong idea.
Yes, a bigger model is a more capable pattern matcher, but it is still subject to hallucinations, and it still has a context window limit.
This brings us to the grand takeaway of our January 2026 guide. AI is not magic, and it is certainly not a person. It is a highly complex pattern-based system.
That is the core of it.
It has specific strengths, it has strict mathematical limits, and it operates through multiple layers of human shaping and intervention before it ever reaches your screen.
This raises an important question regarding how we integrate these tools into our daily lives. You should use AI for what it actually excels at: speed, structure, drafting, and language support.
Absolutely.
It is unparalleled as a tool for organizing text, summarizing long concepts, and brainstorming. But you should never rely on it as a final authority for truth, factual verification, or real world judgment.
That is a crucial distinction.
The entire point of the HowAIModelsWork.com guide is to make AI less mysterious, not less impressive. By understanding the mechanics, tokens, predictions, and context limits, you can harness its real capabilities without falling into the traps.
I want to leave you with a final thought to mull over. How much of our daily frustration with AI comes simply from expecting human judgment from a machine built purely to predict language?
Hmm.
Think about it. When it forgets an instruction or hallucinates a fact, we get annoyed because we assume it knew better.
Right, we project intent onto it.
Exactly. But if we change our expectations, if we start treating it like a brilliant high-speed calculator for words rather than a hidden person, does the tool suddenly become much more useful and much less frustrating? The full January 2026 guide and all the articles we discussed today are available at howamodelswork.com.